Yes, welcome to DC Economics. So I'm going to take you on how we can solve the Pigovian tax. So this is among the very important topics on coverage on externality. So let's begin. A cement plant is accused by the resident in the neighborhood for polluting the air. The government has recently received these complaints and wants to fix the problem. Assume that the invested money function for the cement, which is also the marginal benefit curve, is given by taking out P raised power of D, which is equal to 24 minus Q. So the PD represent out what is known as the invested demand function of the cement, which is called the marginal benefit curve. So whereby Q is the quantity of the cements in millions tons per year, and the PD is the price of the consumers pay in Tanzania shillings per ton for buying cements. So the inverse supply curve is also called the marginal private cost, is given as the marginal private cost, which is equal to 2 plus Q. That is MPC given as is equal to 2 plus Q, where the MPC is the marginal private cost when the industry produces the Q, the output. So the cement industry emits 1 unit of pollutants for each ton of the cement. So it produces that goes into the air, as you can observe. As long as there are fewer than 2 million units of pollutants emitted each year, the external cost is zero. But when the pollutant exceeds 2 million units, the marginal external cost is positive. And the marginal external cost curve is given as taking out zero, that is when Q is less than or equal to 2, and negative 2 plus Q, whereby Q is greater than 2. So whereby MEC is given as marginal external cost, the marginal external cost in Tanzania shillings per unit of pollutants when Q units of pollutants are released out. So we are required actually to the part A to calculate what are the equilibrium price and quantity for cements when an externality is not yet mitigated. And B, to find the quantity of cement that will be supplied by the market at the social optimal level. But also part C, suppose that the government wants to impose a Pigovian tax of 1 shillings per unit of pollutants or pollutions. Now we're required to calculate out the Pigovian tax that would make up the cement industry to produce the economically efficient quantity of the cement. So part A, we require to calculate the equilibrium price and quantity for cements when an externality is not yet mitigated, and B, to find the quantity of cement that will be supplied by the market at the social optimal level, and part C, suppose the government wants to impose a Pigovian tax of 1 shillings per unit of pollution, required to calculate a Pigovian tax that would make out the cement industry to produce the economically efficient quantity of cement. Now let's go quickly to a solution. So we need to write down what is known as the data given from our question. So we have the inverse demand function that is actually given as the marginal benefit curve, that is 24, which is equal to 24 minus Q. So it's given as 24 minus Q, where PD represent out marginal benefit curve, as I told you. But also we have the inverse supply curve. That we call it the inverse supply curve, or sometimes we call it the marginal private cost. We normally write the MPC or MC, which is equal to 2 plus Q. But also we have the marginal external cost as well. Marginal external cost curve that is given as 0, whereby Q is less than or equal to 2, and negative 2 plus Q, that Q is greater than 2. So part A, we are required to calculate the equilibrium price and the quantity for cements when externality is not yet mitigated. So the equilibrium point, in order we can solve the price and the quantity at equilibrium for the production of cement, we need to equate out the marginal private benefit together with the marginal private cost. So we equate out MB, the marginal private benefit, that is 24 minus Q, and the marginal private cost, that is equal to 2 plus Q. So we'll take out 24 minus 2. 2 will be substituted in the left hand side, and Q will be added in the right hand side. So it will be 24 minus 2, which is equal to 22, is equal to Q plus Q is 2Q. We divide by 2 both sides. So the equilibrium output for the cement production will be equals to, if the externality is not yet mitigated, is equal to 11. So we find out price by take 24 minus Q. We plug in the values of Q, that is 11. So it will be 24 minus 11, that is equal to 13. So PD will be equals to 13. So the equilibrium price and quantity for the production of cement when externality is not yet mitigated will be equals to the price, which is 13, and the output, which is equal to 11. Now, after taking that, let's come to B. So part B, we are required to calculate what is known as the quantity of cement that will be supplied by the market at the social optimal level. So the quantity of cement that will be supplied by the market at the social optimal level is given by taking marginal social cost, that is equal to MB. So remember, marginal social cost is equal to MPC plus marginal external cost. So when we equate the two equations, we obtain marginal social cost is equal to 2Q. So we equate out the marginal social cost is 2Q is equal to 24 minus Q. We find the value of Q by dividing by 3 both sides. So the value of Q will be equals to 8. So the economic efficient quantity of cement production is 8 million tons per year, as you can observe. But lastly, we're required to calculate the Pigovian tax. So the Pigovian tax is obtained from the output from the optimal level. Since the output from the optimal level is 8, and suppose the government wants to impose a Pigovian tax of 1 shillings per unit of pollution. So when you calculate the Pigovian tax, it would make the cement industry produce economically efficient quantity of cement. This will be given by taking out negative 2Q, negative 2 plus Q. So when you plug in the values of Q at the optimal level, that is 8, the Pigovian tax will be equal to 6. So that is how we do. So that's mark the end. I welcome you to DC Economics. Don't forget to subscribe and watch on other videos. Bye bye. See you next time.